your time 1 plus your time 2 is equal to your total. I'm looking, what are my common denominators? This one is a plus x, and this one is a minus x. So I'm going to multiply this one by the minus x. I need to make sure that it's 1. And the same thing over here. This is plug and chug. This is algebra, almost algebra 1 material at this point. Okay, because all I did was multiply 76 times 300 minus 2x. So I multiplied, and then I did the same thing over here, plus 76 times this quantity. What happened to these two? They canceled out, and I had 22,800 plus 22,800, which is 45 over 600. And my denominator is 900 minus x squared. Okay? So now they're asking, I think the question was, give me some possible scenarios. So I said, well, if there's no wind, okay, what would the time be? Approximately, and if there was rounding involved, 0.51. And if it was 10, okay, it wasn't a significant difference. It actually was the same. It was about 0.51. Okay, why was it so close?
It's not much.
Yeah, it's not much of a difference with that size of numbers. Okay, and then when x was 60, again, it wasn't much of a difference when I divided it. Okay? Plug and chug. Okay? Is everybody okay with that?
Yeah.
All right. All right, so take out your notes and we're moving on.
Did you ever take our homework?
No, I didn't. I'm giving you credit. All right? I gave out candy today. It was a freebie for you. Okay? All right. Okay. Where is Jess? Just realized
Not
she's
here
today.
today.
All right. So, this next lesson, the idea is very, very simple, but very, very important. Okay? So I just want you all to make sure we're going to be talking about rational functions. Okay, now we've talked about quadratic functions, we've talked about cubic functions, linear functions. Okay, and we're going to be talking about rational functions. Okay, and basically a rational function, and I'm going to go with my marker, rational functions we're going to have rational functions are rational expressions written let me see. Okay, are polynomials, okay, and polynomials, so I could have f of x, okay, here's my rational function, and I could have, let's go with p of x over, I don't know, q of x, doesn't matter what it is, okay, and so what we're going to be doing is we are going to be looking at polynomials that are rational expressions that are going to be written in this form. So, if I had x squared plus 5x, is that a polynomial?
No. Binomials.
Yeah. It's a polynomial. Happens to be a binomial, but it is a poly meaning one, more than one. Okay. Okay. Now by definition, polynomial is not by definition, a polynomial does not have a variable in the denominator, and that's why we're calling this a rational function. Okay, so this is a rational function. Now, what do you know about,
Is that a question? Are rational expressions polynomials?
oh, well, I'm sorry, what was your question?
Or is that a question? Are rational?
No, rational functions are rational
So they're
Oh,
expressions. Yes, okay, sorry. Okay. Yeah, okay. So, what do you remember about division by 0? Is that possible?
No.
No, it is what?
0.
No, it's unknown.
It's undefined, all right? We say it's undefined. Okay, and what do you know about this?
Equal to 0.
0.
That is equal to 0, okay? All right, so what I'd like you to do is let's graph this, and let's see what happens.
Which one are we grabbing?
Oh my goodness, x squared.
Oh.
Laura, I forgot to ask that question that we were talking about the other day about the graphic calculator. Remember with your parentheses? So I forgot to ask somebody else, because I haven't had a chance to think about it myself, so I will. Because and I gave you credit on your
Just
account
type
for that.
verbal.
And I got your other email, I haven't had a chance to deal with that.
Verbal.
All right, so and this is being divided by what?
It needs to type verbal.
Whoa. Mine has a straight line down the middle. Why?
Oh, because yours has.
Okay, so you might want to go to Zoom, and let's go to Standard.
Wait, what are we doing?
I don't know.
What's your line?
Oh, graph that.
Okay, everybody have something that looks like that?
Yeah.
How come?
Wait, you guys.
You don't?
Mine has a line going straight down between.
You may have a line through it. Anybody have a line? I see yours.
Mine has a line.
Okay, this is Cassie's. So hopefully, some of you may have something that looks like that. Mine did not. My calculator does not have this line.
Mine looks just like that.
Let's look at this. So if I said to you, what is the domain? Domain refers to what?
X.
All the x values. Does it appear that this is going to continue? That there are many, many values for x?
Yeah.
And how about on this side?
Yeah. Kind of.
Where is it not?
Where the line is.
It is not at -2. Why?
Because that will make it equal to 0 on the bottom.
If this is a -2, if x is a -2, what happens? We are going to have 0, and so it will be undefined. Okay? So, this is called an asymptote. So I'd like you, in your notes, sketch this in your notebook. Asymptote, where did we see asymptotes?
You're making it.
Conic sections.
In conic sections in particular?
Correct.
Hyperbola. Okay, can this get, Emily, does this get very, very close to the -2? It can be anything, and if we were to zoom in and we'd get as close and close and close, but will it ever be a -2?
No.
No. Okay, and then let's just check that on the tables. Remember, second table. And look what happens at -2. There is what? An error there because
It can't be that.
it can't be that. Okay, does that make sense to everybody? Okay, so if I said to you, could we, where are the 0 figure out where the zeros are, and we can certainly look at the graph.
X is,
How come
Here, thank you.
I got 2 and a 0?
Okay. Okay, so I can look at that. I can also, how can I figure out where my zero is going to be?
How come I
Your
don't have
second
that little
trace.
line that you had?
Okay, mine doesn't have it, Cassie's does. I don't know why mine does.
Maybe
Okay,
because mine's an older version.
okay, so I don't know. I have a T, oh,
I have an
a TA.
83.
Okay, so I know that it's going to be a zero here at 0. Does that make sense? When x is 0, 0 squared plus 5 times 0 is 0. Does that make sense? I'd still have division by 2. And I can see that, or what is the other value where my graph is equal to 0 would be at what? -5, right? 1, 2, 3, 4, 5. Okay? Again, I could do second table and look to see when is there. Whoops, I want to scroll up.
Why are they, yeah, why is always,
Now, I guess we need to change the table.
Wait, how did you get to the table again?
Second, and then it says table.
What's it say?
Mine isn't in decimals.
What's it say?
It is, how about this? Second table set. This is saying automatically, but if I wanted to give it a thing and say ask, so I'm going to say enter, and I'm going to go back to table. And if I say when x is 0, they'll tell me when y is 0. So I can ask it to tell me when will it be at a 0. Okay? Okay. All right, let's do something else. This one is, I'd like you to graph. All right, so in your notes, let's talk about an asymptote. I keep misplacing these markers. Okay. So we say that a graph is